Hey everybody, this is Larry. This is day 22 of the February Leetcode Daily Challenge. Last week, make it count. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, other problems, whatever you like. And let's go with today's problem. Longest word in dictionary through deleting. Okay. Yeah, so I usually solve these live, so if it's a little bit slow, let me know, or whatever. Okay, so given a string and dictionary, find the string and dictionary can be formed by deleting some character of the given string. Okay. Return the longest word of the lexicographic mode. Okay. So the size of the dictionary is 1,000, and all this each string length is 1,000. So if we just go one character at a time, and then we go one word at a time. Is that fast enough? No, that'll be too slow, right? Because that's 1,000,000 characters times each character. Well, yeah, if you do it naively, then definitely it's true. But I think there's some like parallel playing around with it that you can do. By keeping track of where, yeah, I mean, I think we just keep track basically for each string. We just do it in parallel. I think that's fast enough because is that fast enough? If each character, or if each word, then it's just 1,000. 1,000 times the size of the input of the string. So yeah, that should be okay. Yeah, okay. I think so. This one, I think the hard part is just a lot of what I call bookkeeping, which means just keeping track of things to make sure that, you know, and we have to do that in constant time. I'm gonna play around this idea though. Maybe I'm a little bit off right now, but I'm struggling a little bit with the complexity, or proving the complexity to me. But basically, the idea that I would have is, now I'm thinking a little bit about implementation. Yeah, so what is it? So I would have maybe, let's just call it lookup for now. I'm terrible with names, but basically, what does this do, right? This maps a character to pointers in D, right? And that's basically the idea. And then now we can do for index word and enumerate D, and then we just do it from the first character. So lookup of the first character, which is word of 0, we append it, so the word index and then the character index, which is 0 in this case. Okay, and then now for each character at a time. So basically what we do is that you can look at it as, so let's start with a D, the list, the dictionary list, where we have 2 words, right? So basically the idea from here, and I'm just explaining a little bit, I think I know how to do this by now, but basically you have, you know, let's say you have an input. Actually, let's just do this input, right? So the way to thing that we want to do is optimize so that we can do this very quickly. Okay, let's find all the characters where we want to compare A, right? So basically we have 4 words. We have owl, we have apple, we have monkey, we have preed, right? And to perfectly match this word, we just have a pointer at a time. Oops, at the P. And the idea is that, okay, now they have an A. For every word that has an A, we move it forward. And then now we go to the B. Nothing, we don't move anywhere with the B. With the P, well, we move the P forward, we move the P forward. C, nothing. Another second P. So we move this P forward and that's it. L, so we move this L forward and this L forward. Y, okay, so this is good. So we do some math. and then A. Also, this is Y is good. Oh, and this is Y too. Wow. Oops. And then Y. Oops. How did it happen? Y, and then last one is A. Oh, and this is Y, and then this is A, right? So basically, that's the idea that I'm doing, and you just have to kind of implement in a good way, right? Because in the naive way, if you go for every word every time, that's going to be too slow. So basically, what we'd have here instead is a lookup table that allows us to only move the pointers that care, and that's basically what I have here, where we map a character to pointers in D. So that's basically the idea here. Maybe I could explain a little bit more, but I think that's good. Let me know if you have questions in general. Just leave in the comments, ask me on Discord, whichever you like. Okay, so let's see. Okay, so now for character in S, right? So we move the characters one at a time. We also need, let's see. The smallest lexicographic order is a little bit awkward. So maybe we could just sort it. Yeah, actually, I guess we could sort it. Because we only have to return the word. We don't have to we don't have to care about the original order. So we can just sort the index, and then now the word index means that the tiebreaker. So the first tiebreaker will be length, and then the second tiebreaker will be earlier in the sorted list. Okay. So now we have a best index is equal to none. Maybe we can use another number, but it's fine. And this is basically what we're going to return from D. And then now we just do it one at a time. So then we look up sub C, or if C is in lookup sub C, maybe that's fine. I mean, it'll be no. But so for, we have to clear it. That's why. I don't know. I actually don't know how the underlying works for this one. So we'll check out. For example, we do something like X is equal to lookup sub C, or current is list is equal to lookup sub C. Can we do lookup sub C dot clear? Would that fix current list? Let's take a look. I actually don't know off my head whether this is the case. Yeah, that's unfortunate. So basically, we just have to do a copy then. That's fine. And then if I run it again, it should actually have not empties. Yeah, there you go. Okay, so that's fine. Yeah, though maybe that doesn't matter that much, because maybe that doesn't matter that much actually. So yeah, let's play around with it first. So yeah, for word index, and then or dictionary index, maybe dictionary index, and then character index. Maybe word index is better. I don't know. In lookup sub C. So now we want to modify it so that lookup, we want to increment the char index, right? Yeah. So yeah, so now we want to increase the char index. So then we want to put the next character in it. Okay. So yeah, word is equal to D sub word index. Maybe I don't even need that. So yeah, if char index is greater than or plus 1 is less than the length of this, then we just put it into the next one, right? So D sub word index sub char index plus 1, and then we append it with the word index and then char index plus 1, right? This has to be a tuple. But then otherwise, that means that we have reached to the end, right? So then now we can check whether this is good enough. So if best index is none, or length of D sub word index is greater than, oops, typo, length of D sub best index, or they're equal. This is a little bit awkward. Or they're equal Is this right? Or the equal and then we want the lower index if they're the same. So and would I say word best index should be small and best index is greater than word index, then we do best index is equal to word index. And I think that's mostly it. And then now we clear it because we append it to the other places, and then we can return these of best index. Is there a cannot find case? Return the empty string. Okay, so yeah, if best index is none, return empty string. Let's give it a go. Just at least run the code. Ooh, one-time error. Oh, I always forget. I think I need something like this or something, right? Yeah, Apple's good. Okay, sounds good. Let me try one without any good response. Right. Seems to be at least responsible. Okay, yeah, let's give it a submit. Ooh, wrong answer. Huh. Ooh. Maybe I have a typo somewhere. This should, I mean, because I just moved this up. So, and so I would, so one thing I would say is when you see a wrong answer, it matters what the actual output is for obvious reasons. But one thing, for example, is that I noticed that my output is bigger than expected. That means that something went wrong in general, right? Because if this is smaller, that means that you may think maybe there's an algorithm, maybe I didn't do good enough. But that means that I'm just producing a wrong answer that's not in the thing. So we have to take a look here. But this is a little bit tricky to debug, it seems like, unfortunately, because this is a mess. But why do I get a bigger number, right? Or a bigger string than what is go? So we can actually just, because if I'm guessing, then this word doesn't appear in here. But I still return it. Maybe I misunderstand the problem. No, but but then now we can debug this because this should return nothing if this is the expected result, right? We could even actually put these both in here, I suppose. Yeah, okay. And then now we can, and I also say that, like, try to reduce your test cases as much as possible, knowing what it is so that you can figure out how to debug it. And now, oh, I know what's wrong. What's wrong is that, I do need, because basically there's a possibility that I insert this back, the next character is the same. Let me see. Yeah, maybe there's two Z's or something. And if the character is the same, maybe there's ZZ here. I actually thought about this when I was coding, but then I think when we were talking about whether I needed it at the same time, I got a little bit confused. So, okay. So current list is equal to lookup C, and then now we have to clear it. And then now we can do this. And I mean, I was thinking about this, but then I just forgot about it while I was doing it. Yep, there you go. Let's give it a submit again. Hopefully this is right this time after I, okay, cool. Yeah, so this is a concurrency issue. I know that I hand waved over a little bit, but basically I was adding, for each item that's on the previous list, I added to the same list, and then I cleared it afterwards, right? So, and that's a no-no because then I lose information, and that's how I got a better answer than I expected. And then after I fix that, I should be okay. So what is the complexity here, right? It's a little bit confusing. There are a couple of for loops, there are a couple of if statements, there are a lot of things that does stuff. The way to analyze isn't just looking at for loops, even though some very often it helps. But in this case, it is that knowing that for each character in the dictionary, right? Each character, what happens to it? Well, it can be inserted here into the lookup table, and then every time it's in the lookup table, it could be incremented, and then that's it. After that, after incremented enough time, it gets out, right? So that means that let's just say O of m, where m, let's say m is equal to the numbers of characters in the dictionary, n is equal to length of s. This is going to be actually O of n plus m, because this for loop is going to be it's going to look at each character in the string once, and then even though this for loop is an inner loop, as we said, each character in the dictionary is only going to be pushed into the list once and also removed from the list once. So it's going to do two operations, and therefore it's going to be m. So this is going to be O of n plus m time, and in terms of space, it's going to be O of m space. So, actually, I guess I do a sorting here. I would say you actually don't need this sort, but it makes the other it makes the comparison a little bit iffy. Maybe you do need the sort, but then it becomes maybe if you don't use the sort, in theory it becomes something like n squared time, maybe, or something like that. Maybe not n squared, but you have to introduce another variable. But okay, so yeah, but let's just call this n log n then, or not n, but n log m. But you could do it without the sorting, but the complexity there is a little bit different, because then you have to do the number of comparison equal to the number of words in the dictionary, right? No, actually, so okay. So if you don't sort it and you do a naive comparison every time, instead of doing this, so the reason I sort it so that I could just check the indexes like this, but you can actually just check the word itself, right? You could do something like, d sub best index equal to, and actually if you do it this way without the sorting, let's comment out the sort right now. If you do this without the sorting, actually each character will only be compared at most once. So this actually, if I had made this analysis earlier, each character will be compared at once except for the best, which will compare all of n all of the number of words in the dictionary times, which is still linear. So it's going to be all of n plus m time. And then in terms of space, it's also going to be all of m, because we don't care about s. And for each character, we add, we have an entry in the lookup table that we keep track of. So yeah, all of n plus m time, all of m space. Yeah, that's all I have for this problem. Let me know what you think. This should work. If it doesn't work, that'll be hilarious. Also, I might have to. I think actually I got the signs wrong, because we want this to be smaller. So. Oh no, this is right. Yeah, yeah, because we want the best index to be smaller. Cool. Yeah. But yeah, so this is going to be linear time, linear space, or sublinear space, depending on how you want to call it. Linear because it's n plus m, where m is the number of characters in the dictionary, and all of m space in general, which is just the number of characters in the dictionary pre-processed in a different way. Cool. That's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and also, take care of yourself. It's almost the end of the month. Treat yourself a little bit if you got this far. And yeah, take care of yourself, take care of others. I hope you do good. I hope you do well. To good health and to good mental health. I'll see you next time. Bye-bye.